Introduction Historic. Welcome to the Ion Exchange Resins course, and let's start with a historical introduction. The use of natural materials with ion exchange power for water treatment dates back to biblical times. In 320 before Christ, Aristotle used an earthenware vessel containing a material with ion exchange properties to produce fresh water from seawater. Long before synthetic ion exchange resins derived from polymers, the first ion exchangers were equipped with zeolites, which constitute a large group of minerals that contain a porous structure. Zeolite is a word of Greek origin that means boiling stone, a phenomenon observed by the Swede Axel Konstrand in 1756. Who observed that after the rapid heating of a mineral, the stones began to jump as the water evaporated. Zeolites are minerals that have a porous structure, such as hydrated aluminum silicate, and that have an open structure that can accommodate a wide variety of positive ions, such as sodium, potassium, calcium, magnesium, and others. In 1818, German chemist Johann Nepomuk von Fuchs discovered sodium zeolite by combining aluminum and sodium silicate. The first studies involving cation exchange date back to 1850 by J. Thomas Way. In 1905, German chemist Robert Ganz discovered that zeolites could be used to soften hard water. The first commercial zeolite was obtained by combining kaolin or kaulinite, sand and ash. In 1934, with Adams and Holmes, there was a great advance in the area in which it was discovered that cation exchangers could be regenerated not only with salt, but also with acid. This was the first step in the modern ion exchange process. Later work led to development of sulfonated styrene resins and the polymerization of styrene and divinyl benzene. In 1950, the definitive milestone was reached. Based on the research of Gaetano Frank D'Alelio in 1945, Cunning and Myers developed and patented the process involving sulfonation, cross-linking, and polystyrene. These advances were followed by McBurney, who around 1952 developed the styrene divinyl benzene copolymer, which was the basis for the definitive establishment of ion exchange technology. There is academic interest in whether the ion exchange process is an absorption or an adsorption process. AD is a process that occurs at an interface or surface involving the interaction of ions. AB, absorption, involves the incorporation of a substance in one state that attracts another in another state, such as solids attracting liquids throughout their entire structure. So the phenomenon of ion exchange can be placed in both categories and can therefore be more safely considered as an sorption process, a term that avoids controversy among these most devoted to the prefixes AD and AB. Finally, what are ion exchange resins, and what is this process for? The ion exchange technology used for water treatment is a process in which a granular filtering medium composed of microspheres varying between 300 and 1200 microns, composed of polymers and electrically charged, aims to attract certain types of ions to itself, depending on the constitution of the end of the polymer chain. The process normally takes place inside a vessel, usually cylindrical, and as the water passes through the resin, ion exchange takes place when certain undesirable ions are removed and replaced by more desirable ones.